We've now got the contents of our contract all put together. Now thinking about our project itself, we're going to start working very quickly on the compile.js file. The reason we're going to go directly to the compile.js file is that both the deployment process and the testing process is going to expect that we have a compiled contract ready to go. So in order to do any testing or any deployment, we first have to solve this compilation step. To do the actual compilation step inside of our project, we're going to make use, to the Solidity compiler. Remember, we're going to pass some contract source code into that compiler, and then that is going to spit out the ABI, which is our JavaScript interpretation layer of what the contract is, and also the contract bytecode, which is what we actually deploy off to the Ethereum network. To install the Solidity compiler, we're going to install a tiny little node module. Back at my terminal, I'm going to make sure that I'm inside of my project directory, and then I'm going to install the Solidity compiler as an npm package by running npm install --save solc. Solc is the actual Solidity compiler, and as you might guess, it stands for Solidity, that's the SOL part, compiler, that's the C. It's a pretty small module, so we'll just start the installation and then flip back over to our code editor. Inside of my root project directory, I'm going to create the compile.js file. So I'm going to make new file, compile.js. Now, actually making use of the Solidity compiler is pretty straightforward, but there's just one little hoop that we have to jump through. You might be thinking that to get access to this file, we could write some type of require statement. You might be thinking we could write something like require contracts inbox.sol. And that's not the case. This is bad right here. Remember, whenever we require a file into a node project, the node engine will attempt to execute that contents of the file as though it were JavaScript code. So if we attempt to require in the contract file, it's going to immediately throw an error saying, hey, this isn't JavaScript code that you're requiring. So rather than attempting to directly require in this file, we have to read the contents of the file off of our hard drive. To read the contents out, we're going to be making use of two separate built-in standard library modules. Let's require both these modules at the top, and then I'll tell you about exactly how we're going to use them. We're going to first require in path, and then we'll also require in fs. Again, these are standard modules, so we don't have to npm install them at the terminal. The path module is going to help us build a path, like a directory path, from the current compile.js file over to the inbox.sol file. The reason we're going to use the path module for this, rather than attempting to just write out the path directly, is that by using the path module, we are guaranteed to get cross-platform compatibility. In other words, if we try to run this compile script on either a Windows system or a Unix-based system, the path module will make sure that we always generate a valid path. So let's first start off by generating a path to the inbox.sol file. I'm going to say const inbox path, and we'll call path.resolve. And then we're going to pass in three portions of the path. The first portion is going to be underscore, underscore. So this is two separate underscores right here, dir name. Dir name is a constant that is defined by node, and it always gets set to the current working directory. So that will take you from your root directory or your home directory on your computer all the way to the inbox folder. Then the two separate second arguments that we're going to pass in here are going to be the contracts folder and the inbox.sol file. So we'll say contracts and inbox.sol. Okay, so again, this is going to generate a path that points directly to the inbox.sol file, and we're jumping through this hoop right here of using this function to make sure that it works on either Windows or Unix-based systems. Now that we've got our path, we can attempt to read in the contents of the file. So we're going to read in the raw source code from our contract. To do so, we'll create another temporary variable, and I'll call this one simply source. To read in the contents of the file, we're going to use the file system module. I'm going to say fs.readFileSync. I'll then pass in the inbox path, and then we have to specify what type of encoding is used for this file, or for the inbox.sol file. And for both you and me, it's going to be UTF-8 encoding. Okay, so now that we've got all of our source code from that contract file inside this source variable right here, we can now write the actual compile statement by using the Solidity compiler. We'll first start by requiring in the Solidity compiler at the top. So I'll say const solc is require solc, and then we can call solc.compile. We'll pass in our source code, and then we also have to specify the number of different contracts that we are attempting to compile. In this case, it's just one. And that's pretty much it. Now for right now, we're going to just console log the output of the compile statement. And that'll give us a better idea of what the compiler is doing. So let's just wrap that compile call in a console log, like so. All right, let's take a break here. We're going to come back in the next section and run this compile file and see exactly what the compiler is doing for us. So I'll see you in just a minute.